Hi, I'm Sami Aref from University of Toronto, and together with Aref Neal from Michigan State University, we're going to talk to you about identifying splinter coalitions in the US House of Representatives by optimally partitioning sign networks.
I suppose many of you are familiar with this plot that shows the political divide in the US Congress. So in this plot, we have the blue curve representing the ideological position of Democrats and the red curve representing the ideology of Republicans. And you can see that over time, the Democrats have shifted to the left and Republicans have shifted to the right, and in more recent sessions, there's not that much overlap in their ideologies. So, but this sort of analysis disregards the collaboration patterns of legislators because it assumes that Democrats work together and the Republicans work together, and that's why it can be improved when we consider the collaboration patterns of legislators, which may also include some bipartisan collaborations. So in a previous work, which is accessible with this QR code, we use the collaboration networks of legislators inferred from bill co-sponsorship data and the idea of structural balance to partition these networks into coalitions, and then we looked at the party membership of the largest and therefore controlling coalition. In this work that we're going to present today, we use collaboration networks again, but with a slightly different approach for a different research question. So we're going to use weak balance or generalized balance, which gives us more flexibility into partitioning the networks. And we also make use of legislative effectiveness data on these legislators, which represent how effective members of the US House of Representatives are in passing bills.
So in the sign networks of legislators that we create, nodes represent the legislators. So here we have two members of House of Representatives, Earl Blumenauer and Sheila Jackson Lee. And for the age between these two legislators, we look at the number of bills they have co-sponsored together. So these two legislators have co-sponsored 242 bills together, and we compare this number against the number of bills that they would have co-sponsored if each legislator randomly chooses which bills to co-sponsor. And based on this comparison, we can see that 242 bills is much smaller than what is expected by chance in the null model. And because of this, we consider a negative edge between these two legislators.
So based on the method I briefly described, we use bipartite data on bill co-sponsorship to create sign networks. And these data essentially tell us who has co-sponsored which bill. And there are 19 waves of this data for 19 sessions of the US House of Representatives over the time period 1981 to 2018. So we create one sign network for each session, which is a 2-year period of the House of Representatives. And in each sign network, we have roughly 435 nodes representing 435 legislators in the US House of Representatives.
To tell you more about the details on how we create these networks, we use the backbone package in R, and these are the main commands for using this package, which is available from CRAN. And you may also check out this 2021 article from PLOS ONE, which is about this R package. So as you may imagine, we're making a hypothesis test for each pair of legislators, and therefore we need to control for the family-wise error rate. So one of the advantages of this package is that it gives us the opportunity to make a Holm-Bonferroni adjustment and control and limit the family-wise error rate to a predefined value. In this work, we use a family-wise error rate of 0.01.
So how do we analyze these networks, you may ask? We analyze them based on structural balance theory. So as many of you know, structural balance theory suggests that a sign network is Balanced if and only if its set of nodes can be partitioned into two clusters such that positive edges are within clusters and negative edges are between clusters. And according to Davis in 1967, if the same condition is satisfied with K clusters, which could be more than two, then the network is called K-balanced or weakly balanced. So what we're going to do with these signed networks of legislators is to partition them based on generalized balance or weak balance into K clusters. And K could be 2, 3, or larger values. And then look at the edges which are inconsistent with those partitions. So these inconsistent edges are also called frustrated edges, which are negative edges within clusters or positive edges between clusters. And then when we want to compare the fitness of two different partitions on a given network, we consider that the partition with fewer frustrated edges is more suitable and represent the underlying structure of the network in a better way. So in the next couple of slides, I'm going to provide results on this comparison of finding the most suitable partition of signed networks of legislators. So here on the y-axis, we have the number of frustrated edges, and on the x-axis, we have different methods for partitioning these networks. So as you can see, we have party on the x-axis, which means partitioning the legislators into two groups based on their party affiliation. And when we do that, there will be 920 frustrated edges, which means that there are 920 sources of inconsistency with the idea that Republicans only work with Republicans and Democrats only work with Democrats. Then when we use an optimal K partitioning based on K being equal to 2, the number of frustrated edges goes down to 280. So we get a much better fit when we use this approach, this network-based approach. And then when we use 3 clusters, so when K is equal to 3, you can see a further decline in the number of frustrated edges. And then from 3 onwards, for larger values of K, we see only some marginal decline in the improvement of the fitness of the partition for these networks. On this slide, we have more sessions of the House of Representatives, and we see the results that we had for 1907 session in the previous slide that are rather similar for the other networks as well. So we see the general pattern that partitioning based on party affiliation leads to relatively many frustrated edges. Then the next best thing to do is to use optimal partitions into 2 groups, but still optimally partitioning into 2 groups has many frustrated edges compared to optimally partitioning them into 3 groups. And then from 3 groups onward, there's not that much improvement. Now we see the more recent sessions 104 to 109 in red. And as you can see, the red lines are below the blue lines, and this is because of the increase in partisanship and polarization over time. And in more recent sessions, we see that there's fewer inconsistencies to the idea that Democrats only work with Democrats and Republicans only work with Republicans. But still, we see the same general pattern that the optimal 2 partitioning is better than party-based grouping, and the optimal 3 partitioning is better than optimal 2 partitioning. Now you see the most recent sessions in green, which confirm the patterns we observed so far.
This is Aref Neal. I'm going to pick up here with some of our substantive findings. There are many ways that coalitions in the US Congress might differ. Among the most frequently studied are differences in ideology, which can give rise to ideological polarization. But in order to examine differences in coalitions, it's necessary to partition legislators into coalitions. The easiest and most common approach is to partition members by political party. If coalitions are defined by political party, then we observe a familiar pattern of increasing ideological polarization, as Democrats in blue move further to the left, and Republicans in red move farther to the right. We can also partition legislators into coalitions by maximizing the classical balance of a signed network, which places legislators into two groups. Using this approach, we observe essentially the same pattern as before. In this work, we consider partitioning legislators into coalitions by maximizing generalized balance, which places them into three groups. Using this approach, we observe the dominant left-leaning and right-leaning coalitions, but also a new third, smaller coalition shown here in green. Notice that the ideological stance of this third coalition is unstable. In some sessions, like the 98th, it was liberal, while in other sessions, like the 106th, it was conservative. Although legislative coalitions are often characterized by their ideology, we can also consider their effectiveness at passing legislation. In this graph, the blue line shows the effectiveness of the liberal coalition, and the red line shows the effectiveness of the conservative coalition. The background shading indicates which party held the majority in the US House. When these coalitions are defined by political parties, as expected, the majority party is more effective. We observe roughly the same pattern when these coalitions are defined by classical balance. However, when coalitions are defined by generalized balance, we observe something different. As expected, the liberal coalition is more effective in Democratic majorities, and the conservative coalition is more effective in Republican majorities. But members of the third coalition are almost always more effective than either. That is, using generalized balance to identify legislative coalitions allows us to detect an ideologically fluid coalition of super effective legislators. This led us to wonder how these super effective legislators coordinate their political ties. The top panel of this figure illustrates that, like members of the liberal and conservative coalitions, the majority of their positive collaborative ties are with members of their own party. However, the bottom panel illustrates that, unlike members of the liberal and conservative coalitions, these super effective legislators maintain negative opposition ties with members of both parties. That is, these ideologically fluid, super effective legislators avoid partisanship by pushing back on both their own party and the opposing party. Many of these findings are visible in depictions of the signed network, where positive edges are shown in green and negative edges are shown in red. This figure illustrates the network during the 101st session, when the House of Representatives was controlled by Democrats. The majority coalition, composed mainly of liberal Democrats in blue, appears in the middle. The minority coalition, composed mainly of conservative Republicans in red, appears at the bottom. The third coalition appears at the top, and in this session was relatively liberal, ideologically aligned with the majority coalition. The size of the nodes indicates each legislator's effectiveness. Notably, legislators in the third coalition at the top are much more effective than legislators in the majority or minority coalitions. The same findings appear in this figure, which illustrates the network during the 108th session, when the House was controlled by Republicans. Here, the majority coalition of conservative Republicans appears on the left, while the minority coalition of liberal Democrats appears on the right. The third coalition appears at the top, and in this session was conservative, ideologically aligned with the majority coalition. Again, members of this third coalition were much more effective than members of the majority or minority coalitions.
Here are some references, and we welcome your feedback and questions. Thank you very much.